Started now.
No, you started YouTube.
You started to YouTube. You didn't start the webinar.
There's at the top, you need to start webinar.
At the top, you need to start webinar. You see where it says you're in a practice session, attendees cannot join? Now the webinar is live. This will work now, right?
Yes. All right, I'll hang up and start.
Okay.
Thank you, guys.
Where is it?
Nope, that's not me.
Yes. I hope I did.
Yeah, the ad's running now, but we don't have audio from it. James, we're just hearing your audio from your phone.
That's all you heard? Okay, well, go ahead
Yeah.
and start it. The webinar. Sorry, guys.
Okay, good afternoon, everyone. We got off to a little start here, but this is the Hamcation 2021 seminar for kit building techniques for success. And our presenter today is going to be Joe Eisenberg, K0, November Echo Bravo, and I'll turn it over to Joe. How about you, sir?
All right, thank you. Sorry about the late start. Looks like you guys are having some technical problems. I'm going to share my screen and we'll see if, and now I have a problem. So something didn't go right here. So let me see here. Okay. And let's see. All right. What we're going to do is we're going to try this again. And there we go. Now you're going to be able to see it. All right. Now you can see my slides, correct?
Yes, sir. You're good to go.
All right. Thank you very much. We'll start off real quickly, tell you who I am. I was first licensed in 1969. My Elmer was Leo Meyerson, W0 Get Fat Quick. And Leo was the founder of World Radio Laboratories in Council Bluffs, Iowa. And so that's where I took my novice test. I'm originally from Omaha. And I don't actually work there daily anymore. I need to change that because I'm only part-time. I work barely a day a week. I'm mostly retired now. I live in Lincoln, Nebraska. My job has been an IT field tech. So I fix broken printers and networks and servers and things like that. I've been writing the kit building column in CQ since 2009. And I'm a contributing author to the ARL handbook, updating the construction techniques chapter since the 2014 edition. If you see me carrying cameras at Hamfest, because I take lots of pictures, and my best artistic photos I enter in the state fair. I first went to Dayton in '75, and I've spoken there 30 times, and I have a YouTube channel where I have slideshows that are all set to music, all about Hamvention. So let's talk about the kit suppliers and find out who's in and who's out. Well, number one, it's almost easier to, let's look at who is in the business right now. QRPkits.com and QRPguys.com have a lot of really good low-cost kits, work wonderful. 4SQRP.com is the 4-state QRP group. And they finance the annual OzarkCon in Branson, which this year is going to be a virtual gathering. And we have build-a-thons and so forth there and all sorts of speakers about building as well as QRP. Velleman makes lots of kits. Elenco, Elecraft makes some very well-documented kits. Some are kits that you solder and some are kits that you just put together. DZ kit makes a very high quality HF transceiver kit, very, very well documented. MFJ makes lots of kits, especially under their Vectronics name. Nightfire Kits comes from there in Florida, maybe an hour away in Ocala. They're available at vakits.com. QRPME is in Maine, and that's Rex, who does the tuna tin kits and lots of other neat little QRP kits. There's lots of Chinese suppliers that we'll mention later. Heathkit, they make a clock and some other things, but not very many. And there's lots of clubs like the 4-State QRP group that make kits. Of course, Heathkit went out in the early 90s. Ramsey Electronics was a huge exhibitor at Hamfest. 1 year at Dayton, they had 3 different booths, but they're out of business now, and you still find them sometimes on eBay. Tentec also is out of the kit business. So the first thing we want to talk about is you want to make a list of things that you need to use or test it once it's assembled. So do you need a watt meter? Do you need a frequency counter? What do you need to test that kit? Do you need a key? Do you need a power supply and so forth? So let's look at some of the things you need. A scope is helpful. A multimeter. There's no excuse to not have a multimeter. If you can go to Harbor Freight and get them for like $3 on sale, $6 normally. It's not a fluke, but it actually works quite well. A reference receiver is very helpful. That's going to let you see if there are signals present, because the worst thing in the world is to build a receiver kit, hook it up to the antenna, and hear absolutely nothing. Well, actually, if you're hearing static and noises and stuff, that may be a good sign. But if the band is dead, and of course we're at the low end of the sunspot cycle, that can happen. So you want to have a reference receiver that's a known rig that you know is going to receive. A headset or a speaker. What do you need to hear your kit? A key or a paddle. Some kits require one or the other. A dummy load and or a tuned antenna. That's because a lot of kits that are made for QRP have no VSWR protection. So you don't want to run it into an open lead or a dead short. So you want to make sure it's hooked into a dummy load when you first key it down. Does it need 12 volts DC? Does it need AC power, 9 volt, AA, AAA batteries? What does it need to power it up? Make sure you have those things ready, because some kits that are step by step, you're going to need that battery at different points to see if the power supply part works and so forth. Tuning tools. I highly recommend getting a set of tuning tools. Don't ever use metal screwdrivers and things like that. There are tools available for that, and there's a lot of places online you can buy sets of tuning tools for about $5. Will have most of the sizes that you need. ESD stands for electrostatic discharge. That is a big problem where I am right now, because it's going below zero every night. A little bit ago I looked and it was 3 below zero here. And when you heat that air up to 70 degrees, even with the humidifier, it's still low enough that you can kazap things. So electrostatic discharge, even if you can't feel it, it's a problem. And especially this time of year when you're heating up the cold air. Now, of course, down in Florida, you've got a little bit easier with higher humidity, but you still need to ground yourself and read up about ESD before you work on CMOS parts. Work surface. I like to use a cookie sheet because it has a lip around the edge, so the parts don't go flying off and end up in the carpet or on the floor or in a crack or something like that. A board holder, that's kind of optional. Depends on the style of construction you like to do. If you need something that holds your PC boards. And you can get them ranging from small ones, which I use here for photography for my column, all the way up to large Panavices. The printed manual is great if there is one. I don't recommend using a laptop anymore. I just recommend using tablets, because those little pieces of wire go flying off when you snip those leads, and that could end up inside your laptop keyboard. While if you're using a tablet, it just hits that glass front and it just bounces off. So there's very few openings in a tablet that pieces of wire can get into, especially if the tablet's in a protective case. And you can take your fingers and you can pinch or pull them out so you can magnify the pictures if you're using a good sized tablet. So I recommend an iPad or a good size Android tablet. Those work great if you don't want to print your manual. Otherwise, I suggest printing them in color if possible. Some of the things I highly recommend: assortments of pre-sorted standardized parts. And you can order these from places like Jameco or Newark or DigiKey. You can get these cabinets that already have drawers and have the parts already sorted out in them. So you have the common values of resistors, capacitors, diodes, common transistors, and ICs. You can get these assortments. If you're going to do a lot of kit building, I highly recommend this. And the reason is that because sometimes it might be Sunday night and your kit is missing a 10K quarter watt resistor. Well, you can't go to Radio Shack anymore. So you want to have that kind of thing on hand. And also sometimes there's modifications to kits that come out after the kit is out. So there might be user groups on Facebook or Twitter or places like that, or websites, where you can look and see what the users are doing. And it might be that the audio quality sounds better if you replaced a 100K resistor with a 47K resistor or something like that. And so it's good to have standardized parts on hand, not only in case you have a missing common part, but in case there's a modification that comes up in the future that enhances the operation of that kit. And so you always have that part on hand. 9-volt battery snaps and battery holders are a must if your kit does not come with that, especially if you're mounting it into a case to keep that metal battery from shorting out the parts. A lot of plugs and jacks, like your 1/4-inch plug, 1/8 inch, 2 and 3 conductor, the jacks, phono plugs, jacks, PL259s, and so forth. You want to look at your kit to see what it takes to talk to the outside world and get all that stuff ready before you even start building. Most kits nowadays use a 12-volt coaxial power plug. Make sure that you look to see if it's a 2.1 or 2.5 millimeter and if the center pin is positive. As a general rule, most kits lately, the center pin is positive and it's a 2.1 millimeter, but there are exceptions. And so make sure you double check to make sure that that's really the truth and that you're going to use a 2.1 millimeter with a center pin positive, and check with the meter. Always check your power source to make sure that you hooked up the cord that has that coaxial power plug is hooked up correctly as well. So I always just stick a meter probe in the hole of the coaxial plug and touch the other to the outside. Make sure the polarity is correct, because you don't want to waste all your time working on that kit only to have it go up in smoke when you hook it up to the wrong polarity of power supply. None of us are perfect, so we want to be able to desolder. One of the things I run into the most often is sometimes I drip solder onto another pad that has not been filled yet. So I need solder wick. Solder wick is very inexpensive, only a couple of bucks. And I use that to wick up solder that's not where I want it to be, or to desolder parts. You can also use solder suckers or vacuum desoldering tools. And if you're working with enameled wire, an emery board is a must. The soldering iron is probably one of the most important things you have when you're working on kits. It's really, really important to also be able to have a place to put your roll of solder so it doesn't become a cat toy. This particular one sells for around $60. It is temperature controlled, so it's not hot and warm or whatever. It actually has digital temperature control, holds it within 2 degrees Celsius, and that's pretty much the standard for commercial soldering irons. So this one actually comes from a source here in Lincoln, Nebraska, which I did not know until after I started ordering stuff from them, found out it's coming from Lincoln, and that's extronicusa.com. Now, the way you can tell your soldering iron is ESD safe, which is a must. with CMOS parts is to look to see if the power plug has the third prong. If it's a 3-prong grounded plug, then chances are it is ESD safe. Also look for one that takes a variety of tips and that the tips are easily available. The 15 to 30 watts is kind of a rough guideline. Some of them are higher or lower, but as long as you can control that temperature and it keeps that temperature, that's the best. If you're going to be using those $6 irons, I don't really recommend that at all. A good soldering station is going to be your best chance for success. Let's see here. All right. A variable voltage power supply, especially with dual meters, so that you can check the voltage that's coming out and you can vary it, and it has an ammeter on it so you can see how much current it's drawing, is very helpful, because it's always good to see if it's drawing too much current, because if it is, something's going to get warm. So you want to make sure it's not drawing any more than you think it should. A frequency counter is a must too, and these are getting less expensive as well. And it's a great tool for finding out what frequency your local oscillator or your BFO is on, your mixers and so forth. Frequency counter is a good thing to have. An oscilloscope, when we get our ham flea markets again, I'm sure we'll find lots of cheap ones again. I've been seeing Tektronix under $100 in flea markets before things stopped a year ago. You can even find a scope kit as low as $23 online, and that's at banggood.com. Dummy load, like I said at the beginning, is an absolute must, because you want to present a 50 ohm load to these little transmitters. Otherwise, you might burn them out when you're testing them and lining things up. Vacuum desoldering station or tool, Heiko 808, looks like a big old Weller soldering gun, except it's got a hollow tip. And when you pull the trigger, it sucks the solder into the tool. And there's also smaller versions of that where you have a larger box and it sucks it into a smaller hand tool. Those are great, because if you're doing as much kit building as I am, when you're doing a lot of serious kit building, you want to have something that does that, so that you just put it over the connector and it's a hollow tip iron and it sucks the solder right up into the tool, and then you can just lift the part off. There's an inexpensive version of that. There's a company called American Beauty, and they make a soldering iron that's just a pretty simple one, but it has a suction bulb, and all you do is you squeeze the bulb, then put it over the contact, and then you let go of the bulb and it sucks the solder up. A general coverage receiver is great to have on hand. Like I said, for a reference, it's great for entertainment and testing and checking your band conditions, or even an AM/FM clock radio. In addition to that, it's great for entertainment and time reminders. So you hear that legal ID on the top of the hour, and so it kind of reminds you what time it is. Take a glance at that clock, because when you're winding a toroid or something, time gets away from you. A random wire antenna, string a wire out the window, tie it to a tree or something. That's great for testing receivers. A solder roll holder, you can make one, or you can get one of those soldering irons like I showed, that holds the roll of solder. Now, my doctor's prescription for solder is I use 6337, not the 6040. There's a reason. I use 6337 solder, 031 or 025 thickness, rosin core, no clean. That way you don't get those big brown blotches on the bottom of the board. It looks a lot nicer, and the solder flows a lot better. Now, when you're comparing the 6040 and 6337, and I don't use silver solder very often, only sometimes on connectors, but the 6337 is not silver. It's called a eutectic solder. And what that does is it flows a lot better. In fact, I have customers that are electronics plants right here in Lincoln, and that's what they use. And it's because 6337 has better wetting than 6040. And what that means is that it sticks to the wires and makes a nice coating and flows through the hole in a double-sided board real nicely. And it has a much shorter plastic state. Now, what that means is after you take that solder iron off of that, With 60/40 solder, it may take a few seconds before it cools off enough that you don't get a cold solder joint if it gets accidentally moved. With 6337, the amount of time that it has in that state where you could end up with a cold solder joint is very, very brief. And so it works a lot better, and it's great for what we like to call hand soldering, which is what we do in kit building. And you got to have storage to keep those parts secure between sessions, because the enemy of all kit builders is, there we go, that's Tesla and Newton. This is something that's worthwhile to have if you're working on multiple kits. This is the Plano 1354. And you can find that in different colors depending on where you buy it. This color scheme might be what you might see for fishing and hunting and things like that, and fishing tackle. You can also buy it at a hardware store, and it might be yellow and black. And you might be able to buy it at a place like Michael's, and it might be pink and lavender. So they're all the same. It's just the different color of the outer shell. And what I do is in the top, I put the larger parts, like partially assembled circuit boards, larger pieces, the manuals, things like that. And then the smaller parts I put into one of these 4 trays. And these trays pull out, and they have 3 rows of compartments. And those compartments can be resized to about any size you want, from little 1-inch ones all the way to 5 or 6 inches or more long, by removable dividers in them. So they can be customized for your kit. If I have one of these things, I have like 4 kits, let's say, in progress, and I can put a little label in the front so I know which kit is which. So it's kind of a neat way to do things. And this shows what one of those trays looks like with the parts sorted into it. I have used sometimes cupcake trays, and those are good for ESD because you can attach a wire to it through a 1 meg resistor and ground it. And they come in 6, 12, or 16 hole versions. What I do in any case, in any kind of part sorting, is I put the parts that I use most often closest to me. So you can see the part used most often in this kit is resistors. And then you have the different capacitors and so forth. And then you have transistors, diodes, chokes. Then you have your toroid cores and wire, and you have your knobs and your plugs and jacks and hardware and pots and things like that. So the things that you use most often, I have closest to me, so I'm not reaching over other things to get to it. And then the parts I use least often are in the far back and the far corner. Now, some kits are stage by stage. These are more complicated kits. So what I do is I resize the compartments, and this is a larger one, and you can get these at Walmart and Michael's and Hobby Lobby and places like that. And they also have removable partitions. And what I do is I put a little number in the bottom on a little piece of paper, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And they work back and forth through this. And the reason I do that is that's the stage number. So let's say the power supply is stage number 1. Its parts might be in this little cup here. And when I'm out of those parts, then I know I've completed that stage. So obviously you don't want to run out of parts before you've run out of steps within that stage. So when you're dealing with a more complicated kit, they go from the power supply onward. That way you're only putting in a half a dozen parts or so, and you can hook it up to your power source, and you can check different pins. And what they do is they usually have instructions, and it tells you that you might have +8 volts here, you might have 3 volts there, you might have 9 volts there, and so forth. And so it lets you know if the power supply is working, because after all, if that kit's got 100 or 200 parts in it, you don't want to have to try and troubleshoot that if it was just a problem in the power supply. And so that's first. And then they usually go to the audio amps and so forth, and then they start working with your RF oscillators and so forth. But in a stage-by-stage kit, the instructions have information on what tests you need to perform before you continue on. That way it's kind of easier to isolate problems, because if it doesn't work, you can fix that problem before it's a lot more difficult to find. So each stage might have a half a dozen or so more parts. And so obviously you can narrow down what changed between when you tested the stage before and that one, as to what you might have messed up. You might have put a diode in backwards, the wrong resistor in a spot, things like that. You can fix it before it's a lot more difficult to find and before you damage any parts. So when a kit is stage by stage, there's obviously a smaller number of parts that are put in at the same time. And like I showed before, you put each in their own container so that when it's done, there's no more parts left in that container. And make sure that you have the right test equipment to test each stage. Do you need a meter? Do you need your headset? Do you need a key? What do you need to test that stage? And it will tell you. So make sure before you start on that stage that you have the equipment ready that you need to test that stage. All right. Now, a lot of kits have no sequence at all. So what I do is I start with all the resistors first and then the capacitors and so forth. And I kind of work my way up the hierarchy of parts from passive to active parts. Then I start the diodes and then the transistors and ICs and then other less common parts like your chokes, toroids, things like that, switches and pots and so forth come later. But make sure you look at the documentation in the board, because sometimes it's a little difficult to put in a part next to one that's much larger. So you might need to put that part in first. Now, usually because a kit like that has no sequence, has a lot fewer parts, you're less likely to have an error as opposed to a kit that has like 300 parts you're going to be soldering. So once again, take a look and see if there's any special instructions about handling certain parts and if you have to do one before another. And once again, make sure that the supply of each kind of part, like, are you out of resistors? Are you out of capacitors when you're done installing all those? Now, there's an exception to that rule, and that is when you have a kit that has different options, like different bands. So like the 20 meter version might use a certain value of capacitor and the 40 meter version might use another. So sometimes they put all those parts in your kit. Sometimes they don't. Sometimes they come with a bag of parts specific to your band. So take a look and double check to make sure if there's a reason that there's an extra part supplied with your kit, because it might be an option, could be a different side tone pitch or things like that. The trouble with toroids, a lot of people don't like building kits with toroids because they're kind of afraid of it. But if you look at this toroid, it's not that hard to do. It just takes time. And what you're looking at here is not just a regular toroid, not a regular inductor, but it's a transformer, because you can see that there are two turns of yellow wire up near the top. So it's got a primary and a secondary. And the way we count the turns in a toroid is we look on the inside of the donut. And so I look at the inside and you count how many wire passes there are through the inside. Now you can see at the first and last one, they don't quite make it all the way around, but that's okay. It counts as a turn as long as there's some of the wire that comes through and makes it through the middle of the donut. The way you strip the insulation off, there's a couple different ways to do it. If it's real thick, what I do is sometimes I take a cigarette lighter and I burn off the insulation. It just turns it black, makes it a little easier to deal with. And then I take an emery board and I shine it up. I clean it all off so it's nice and clean. And then I take my soldering iron and I tin the lead, just like what you see here. That way, when I put it through the hole, it fits just nicely and it makes great contact with the board. And you want a toroid to make really good solid contact, because an inductor is very critical to your RF stages. Now, some of them come with what they call thermalese wire. And a lot of times the instructions will talk about this. And the way you take care of that is I turn the soldering iron heat up all the way, and I take some solder and I make kind of a blob on the end of the soldering iron. And then I put that blob pretty much right next to the toroid, and you hold it there for a second or two and it starts smoking a bit. So you're going to want a little tiny fan sometimes to blow the smoke away if you don't have good circulation. And then I draw it away from the toroid. So what it does is it's melting and burning off the insulation, and it's leaving solder there, which means it's tinning the wires. So it's all ready to go and on the board. Now, what some people do is they do all the toroids first, and then they put it into one of those compartments in their part sorting, and they label each one like with masking tape or so on, like L1, T2, things like that. And that way, when it comes time to do it, instead of stopping and spending 20 minutes winding that toroid while you're assembling the kit, instead of doing that, if you've done these all in advance, you just stick that on the board, poke the leads through the right holes, and away you go. Now, what you want to do is follow the instructions meticulously, because in some kits, especially those involving regenerative receivers or multi-turn and tap transformers, the turns have to be wound a certain way, clockwise or counterclockwise. And that also affects the way the wires fit in the holes in the circuit board. So you want to look at the pictures real carefully and make sure you wind your toroid so it matches what the picture looks like. Otherwise, you might be having to redo your toroid. Common mistakes: some of the RF chokes look almost exactly like a resistor, so check their markings. Get a copy of the resistor color code and also look in the instructions to see what those chokes are supposed to be marked. I use a parts tester, and I will show you the parts tester in kit form here in a little bit. I double check my electrolytics and tantalums to make sure they have the right value and polarization. I use a lighted magnifier to check those little tiny 1/8 watt resistors. And I use a meter if necessary to be sure of the value of those resistors, or a component tester. Look at those diode markings to see if there's a stripe or a black line or an arrow or a flanged edge or something, to make sure that that diode is in correctly. And watch it real carefully when you bend leads, because there's some really fragile parts out there. Those tiny little glass diodes, those little RF chokes, and those itty bitty capacitors are very vulnerable. And sometimes you have to bend the leads a little bit to fit the circuit board because they may have changed suppliers. So be extra careful when you're bending those leads. Sometimes I take a second set of needle nose to hold it next to the capacitor while I bend the wire away from it so that the stress is off of the part. This is a component tester, and you'll see it has leads number 1, 2, 3 at the bottom. I buy those bags of clip leads that are different colors, and I cut them in half. And then I take 3 different color ones, and I strip the end, and I tin that, and I put it into these 3 contact binding posts. And it will tell you if it's like a resistor. You don't have to worry about which goes to which. Like if you have a resistor, it can be 1 and 3, 2 and 3, 1 and 3, whatever. 1 and 2, it can be between any of them. And you hook it up to those posts and you push the button, and it comes on, and it says, oh, this is a resistor and it's 998 ohms. Well, there's your 1K resistor. But it also tells you if you have a diode, and it tells you which side is the anode and the cathode, and it tells you the forward voltage drop. It'll tell you if a transistor is PNP, NPN, CMOS, MOSFET, SCR, thyristor. It'll tell you what kind of a solid state device that is and which lead is connected to which number. So it might say DGS, drain gate source, for a MOSFET, or a emitter-based collector for a PNP or NPN. And it shows you which of those wires is connected to which lead. So if you have a part that's not marked real well or something, you can tell what it is and tell you if it's a good part. You can even hook an inductor to it, like a toroid, and it'll not only tell you the inductance, but it will also tell you the DC resistance as well. Very useful tool. It's a kit, and there's the link to it right there. This is another version of it. This is a kit also, except that you don't do any soldering. All you got to do is put together the plastic case. Wired Communications used to have these. I don't know if they still do, but I have seen these available through Amazon and eBay and through other online stores. And this one, I have a transistor on the left side in the ZIF socket, and it's in 1, 2, and 3. And it's telling you the emitter base collector, it's telling you the gain, and it's telling you the forward drop as well on that. And there's pads in there that you can actually hold in surface mount parts if you're using plastic tweezers. You just push the button, it boots up, and it tells you what kind of part it is and what its value is. The kits that are out there include this one. This is an AM broadcast receiver, and it solders to pads on the board instead of through the holes. So the front panel, if you turn it over, I wish I had a picture of that on this slideshow. But before you assemble it and put the speaker in and everything, where the speaker grill is and the spaces on the other side, it tells you that R1 is this and so forth, tells you the values of each part and where they go. This is a great little kit. This is available from the 4-state QRP group. And like I said, it solders to pads. This is a super great beginner's kit, because instead of soldering through a hole, if you have a part that you put in backwards or in the wrong place or something, all you have to do is take your solder tip and touch it to that lead and just lift it up right off the board. And you can leave that solder there, because when you put something else there, all you got to do is push that lead down with the solder there and bang, it's soldered right away. It's based on a simple one transistor design, but it also has a separate detector, kind of a modernized version of a very simple radio, and it works quite well. In fact, I'll show one at the end. And by the way, the case for that kit is the printed circuit board. So you're soldering together pieces of circuit board, and that makes the case for the kit. And there's lots of kits out there that do that. This is the wall wart tamer. I like to use these for group kit builds. In fact, I did it right there in Orlando a year ago for the club. I use an old laptop power supply for the input, but you can actually put anywheres from 12 volts to 30 volts AC or DC on the input. In this case, I'm using a 19-volt laptop supply, and I've just cut the connector off, and I just separated and tinned the leads so they go right into that connector real nice. It filters it. There's a voltage regulator there, and there's a pot that you can adjust it with. And it puts out anywhere from about 17 volts down to 1.5 volts at 1.5 amps. Reason I like this as a beginner's kit is it's very easy to put together. And now you have a power supply that can power just about any kit. From an old laptop supply, it gets rid of all the hash and noise and RF and what have you that comes out of laptop power supplies, and makes it nice and clean and regulated, and you can set it for any voltage you want. So now you have a power supply that you can run future kits on, as long as they don't draw more than 1.5 amps. These are very inexpensive, and like I said, this is one of my favorites to use for group kit building experiences. This is
Joe?
another. Yes.
We're getting close to the end of the session here. I wanted to see if you want to entertain any questions and answers from the audience.
Okay.
If anybody has any questions for Joe, you can submit them through chat, and I will read them to Joe.
Okay, and I'll zap through these real quick. This is a kit. The coils are made by spiral winding. It's actually etched under the circuit board, so you don't have to wind any toroids. And it's a simple CW transceiver. This is a 75-meter AM transceiver. Both of these kits come from the 4-state QRP group. This one, you see a zillion surface mount parts in there, and guess what? You don't have to do any of those. All you have to do is solder the 30 parts that are not surface mount. Here's kind of my final hints. Keep your soldering iron tip clean. Have all those plugs, jacks, and connectors ready. Use a cookie sheet to protect your table, and take your time and have fun. And this is what I look like when I hit the end of sweepstakes. So,
Okay, Joe, I have a couple of questions.
Okay,
I
I
have
think
one.
I think I cleared the screen, so you should be able to see me.
Yes, you did. We see you. So the first question is from Terry Shoya. It is asking, what is the best normal soldering iron temperature to use for printed circuits, capacitors, IC, etc.?
I operate between 620 and 640 Fahrenheit. That's what I use. For just about anything. That's what I use. The only time I turn it up is if I'm desoldering or if I'm soldering a connector that's kind of heavy and doesn't seem to flow real well, like a BNC jack or something. I'll turn that heat up a little bit more to get the solder to flow. But otherwise, most conventional parts, anywhere from 620 to 640.
Okay, great. And Chuck Bigby asks, are your slides available for us
Um,
in
I
your
can
presentation?
I can probably find a way to get those uploaded, or if somebody emails me, Joe at k0neb.com, I can send you a slide set.
Okay, great. And Bill Brazina asks, what do you recommend for a reflow station?
A reflow station, well, actually the same place Xtronic has one that has the hot air gun that you use for um, uh, working with surface mount parts and so forth, and lifting parts off of the board. And it's not real expensive. So I'd look at Xtronic USA for that.
Okay, great. And some people are asking for links to the kits. So if you could include those links in a presentation there, that would be great.
Yeah,
And then
my second slide or first or second slide has a whole list of the links for those.
okay, and then Bill also asks, do you recommend crimping or soldering on the PL259 connector?
Well, that's a good question because I've just soldered them most of my life. And yesterday I got this big box in the mail from DX Engineering. I ordered a crimp set, and that one's kind of an interesting compromise. It crimps the shield, but you solder the center conductor. I would say use whatever you're most comfortable with, to be honest. But in any case, I wouldn't use anything that doesn't allow you to solder the center conductor.
Okay, and then the last question from Nathan Shepard is, must he have an oscilloscope or can he get along without one?
You can get along without it. I have for many years, and most kits I don't use it, but there are some that it's really helpful, especially for troubleshooting to see if signals are present in different areas. But the scope is just a handy tool when you're troubleshooting. But a good digital meter is an absolute must. I wouldn't build even the simplest kit unless I had a digital VOM.
Great. And I'm going to read what Gaetano Siciliano said, that you did a wonderful job, Joe. Great as usual, from Alpha Kilo 4 Yankee Oscar.
Oh,
And
well,
with
thank
that,
you
I
very
guess we'll be
much.
closing the session. We're right against our time here. And I would like to thank everyone who participated, and welcome again to Hamcation 2020. We look forward to you at some of the other seminars. And I'd like
Yep.
to thank you again, Joe, for your time and expertise. And it's always a pleasure.
Okay,
Thank
and
you,
thank
everyone.
you. And my next session is next, so stay tuned.
Okay, I'm
We'll
going to be
switch.
closing this down
We'll,
and then they
we'll
can
switch
join the other one.
Zooms. Yep, I will too.
Thank you. Good day, everybody.